which is the production of value by human labor and its exchange on monetized market, the reinvestment of surplus labor for further and more production. Of course, there's new dynamics that have arisen, let's say the catastrophic transformation of the ecology or the spread of capitalism all over the globe, which bring their own questions to understand them. But its basic skeleton remains and can be developed further. Of course, Marxist economics is much more than just the work of economists. It's just much more just the work of Marx, and also much more than the work of economists on Marx's, let's say, published works, unpublished works. It's not restricted to the defense of Marx's analysis against later critics. Of course, all these contributions are key for Marxist economics, but so is the extension and adaptation of value theory to further developments of capitalism, especially on the global scale. And I want to mention just three important contributions here, just as illustrations. We have, on the one hand, what we call the first wave of Marxist imperialism theories, which are often identified with Grossman, Hilferding, and Lenin, who they followed Marx's argument that since labor produces new value and capital does not, an increasing capitalization of developed economies depresses the general rate of profit. This is the so-called tendency of the profit rate to fall. As I said, there's this paper by Basu and Manolakos that's really worth reading. And their essential argument was that if I have a capital in a really developed economy where the profit rate has fallen, and they can export that to less developed markets, then they can take advantage of the higher general profit rate there, but also dominate the competition. And this is an underlying pattern that they identify with imperialism. Another contribution is the analysis of unequal exchange in the 1960s, 1970s by people like Aguirre Emmanuel, Samir Amin, sometimes called the imperialism of trade. That's the subtitle of Aguirre Emmanuel's founding book, Unequal Exchange, where they basically argue, okay, so if I have a generalized profit rate on the global scale, if I have a generalized profit rate in general, then this would benefit more capital-intensive industries. And that's also what David Ricardo writes in his writings. But if I now put that on the global scale and I compare some countries which have a mix that is more capitalized of industries, which is the old imperialist core, and I have some countries which are more labor-intensive in their production, and then there will be a steady flow of value transfers from the neo-colonial periphery to the imperialist center. And it's also something that we look into in the book, and we find empirical evidence for, that we find enormous economic significance to that question. And then finally, the role of ecological destruction is really central nowadays. It's not only for a theoretical understanding of capitalism, but it's really for the lived reality of billions of people nowadays. And there's people like John Bellamy Foster or Kohei Saida who discuss this issue in the theoretical framework of value production and what they call, or what Marx actually calls, a metabolic rift. So basically what they say is that capital accumulation on the one hand and natural cycles of depletion and replenishment, that they're completely conditional on each other nowadays. So there's no capital accumulation without natural cycles, but also natural cycles are deeply influenced by the logics of capital accumulation. But they have a huge rift between them in three dimensions. On the one hand, they follow completely different logics. Capital accumulation follows a logic of expansion. Natural cycles follow logics of stability. They have a different time dimension. Just think of coal. In a natural cycle, coal will be reproduced in millions of years, and it will be used up in a single year in capital accumulation. And also, when we talk about localities, there's a completely different logic. Capital accumulation tends to be concentrated in urban centers or production centers, whereas natural cycles are just way longer spread out, spatially speaking, and they tie together different biospheres and so on and so on. And in our book, we also use this idea of metabolic rift to tie Marx's ideas of ground rents to ecological destruction. I'll also show this as one of the applications later on. Okay, so now I spent about half of my time on motivating value theory, which I hope I didn't bore you to death. Now let me get back to our question of testing value theory. And here is just a schematic scheme of how we went about that in our book. As I said, we need to operationalize value theory, then we can either test it or apply it, and this is exactly what we do. I will now show you a simple workhorse model of Marx's value theory to estimate labor values, production prices, and market prices from, by the way, publicly available data, the input-output tables in the Exiobase 3.8 version. I will then show you how we can test, let's say, one central proposition of Marx's value theory, which is that labor values regulate production prices and that production prices are the gravitational centers for market prices. And then I will demonstrate that we could apply Marxist ideas of ground rent and ecological destruction using this data, this operationalization. And of course, many other applications are also possible once we have reached this consistent operationalized model, and ours is just one. There are many operationalized models in the literature which do produce empirical results. But for now, our workhorse model has three layers of analysis. First, direct prices are the monetary expression of total labor, direct and indirect, that go into the production of commodities. It is an expression of a really simple labor theory value. Labor hours go into production of capital. We add them up. That's our total labor hours in a commodity. Calculating them is somewhat simple. We do it in two steps. First, we take the labor hours that are performed in one industry, which is this capital L in the equation here on the total right-hand side. And then we normalize that to the average level of skill in an industry. So let's take a step back here. Every sector employs a differential mix of simple and complex labor. And complex labor takes time and money to be produced, but it's also more productive of value. And this is reflected in persistent aggregate skill differentials between industries. So when we are able to control for price levels, then the deviation of the industrial average wage from the global average wage provides us an appropriate estimation of skill level differentials. And this is what we do in this first equation. We take the industrial wage over the overall average wage, global average wage, and then we multiply it by the number of hours divided by euros of output. That's our labor vector. That's hour of normalized labors that go into the production of €1 worth of output. And then we use this technique of the Leontief inverse matrix. That's this I minus A minus D minus 1 in the last line to add up the labor hours in production of a commodity. So we have this matrix A, which is circulating capital per euro output. We have this matrix D, which is fixed capital per euro output. And we try and also count all the labor that went into multiplying them. This is just the matrix notation of a geometric sum formula. You could either believe me or also just do the calculations on your own there in this equation. But this is how we get this V vector, which is just the number of total labor hours going into €1 of output. And that's our direct price. Now, the second level of the analysis, as I said, are production prices, where competition has formed a general profit rate, which is then added to labor and capital. These production prices are calculated as 1 plus the profit rate. So this is 1 plus R here, times direct labor prices. So that's just labor evaluated in wages, plus circulated and fixed capital. Of course, now circulating and fixed capital needs to be evaluated at the same price basis, production prices. So we bring it again to the left-hand side to the right-hand side. We open up the equation. We simplify the equation, and we now get this new longer formulation of the Leontief matrix A plus D times I minus A minus D power of minus 1, I minus that power of minus 1. This is more complex, so we just call it the H matrix, which is capital coefficients. And one thing that's a bit more tricky now. So here in this H matrix, we just have all the labor hours that went into producing every capital input, but also that went into producing the profit on every capital input. So we need to count on that, right? And on the left-hand side, we have the direct prices that we already had. Now, what is a bit tricky now is that we start expressing both the wage rate and the profit rate as shares of maximum profit rates. For that, we if you're not entirely interested in that, I fully understand, but I'm just going to say that here. For this, we exploit the mathematical property of input-output matrices. Input-output matrices are square and non-negative matrices. That means that they have a number of eigenvectors and eigenvalues. Eigenvectors correspond to some sort of stable state prices, are one interpretation, where the inputs and the outputs, if they are evaluated in the eigenvector, they produce a stable system, and then the eigenvalue produces the speed of expansion of that system. I'm not sure if that makes a lot of sense, because matrix algebra for me is a bit complicated to explain. But what that means is that there is only there's a theorem, the Perron-Frobenius theorem, that says there's only one vector that has only positive entries, and this is of course necessary for a price system to work. And then the corresponding eigenvalue, which we call the dominant eigenvalue, gives you the maximum expansion of the system. Or in other words, the profit rate if we paid 0 wages and 0 taxes, that's the maximum profit rate, which we call capital R. Right. Finally, the only thing that we have left is market prices. We observe them directly from the input-output tables and their relationship to production prices. As we said, this relationship will be turbulent. So production prices will have, on the one hand, a gravitational pull to the market price, but there's also going to be turbulent fluctuations given by investment from market prices away from it. As I said, supply and demand, investment that increases competition, monopoly in ground rents, all of these things, they create persistent market production price differentials. But in the end, with this database, with this operationalization, we argue that the gravitational relationship between market prices, production prices, and then labor values, which we now call direct prices, is characteristic for capitalism and capitalist value production. And at the same time, we say that there's going to be both persistent and temporal differentials, which are the window through which we can look and understand the underlying dynamics, the conflicts, the dialectical contradictions of the system, if you want so, which is to say, really the essence of capitalist development, because that's not a steady state, right? That's a highly explosive and highly growth-worthy system. Now, you think I'm gonna show you results now, but there's one last question that we need to get out of the way, which is the unit of measurement. Sounds really boring. It's mathematically really important. So when we compare price levels, we have to be really clear about the unit of measurement. The case of market price, of course, seems straightforward, right? So we have the input-output tables that give us the sum received in euros for a given industry in a country of year. And this data is already available in one common currency. But under the surface, we find the complications. We have intransparent exchange rates. We have differential price levels for consumer goods, capital goods, and services. The comparison over years is really difficult with differential price growth rates, so inflation between countries and years. And most importantly, we don't have data on unit numbers for the market prices. We know that the paddy rice industry in Indonesia made 6 billion euros a year, but we don't know how many tons of paddy rice they sold. It gets even more difficult with the service industry. Haircuts are not counted in national statistics, right? And at the same time, the direct and production prices are calculated to give labor hours per euro output, which is a different scale. So at the very least, we have to multiply them by market prices to receive the labor hours and profit rate enhanced labor hours per total output rather than per euro output, which leads us to the very simple solution that we normalize direct production prices and market prices by the yearly global sum total of the same price. And each vector now represents shares of global product, gross global product in a given price space. This has two main advantages. On the one hand, we can sidestep for the moment issues of exchange rates and dimensional vectors for the mathematical techniques. And on the other hand, the big advantage is that whenever we want, we can transform these shares back into euro values, labor hours, or any price base that we want to by choosing that global price base. Okay, now to results. Let's compare labor values, production prices, and market prices. And one early form of price value analysis that is actually found in Leontief's own work on a completely different issue, on the Leontief paradox, is just a graphical representation of this linear or almost linear relationship between production prices and market prices. So the main diagram here with the darker dots in the middle represents both of these vectors in logarithmic scale, logarithms, because the interpretation now is that 1 percentage point change in production prices on the x-axis will bring exactly 1 percentage point change in market prices